Hi guys, today we are going to be doing one thing and one thing only. We are going to be graphing compound inequalities in two variables. So many moons ago we had graphed compound inequalities along the lines of x is greater than 2 and x is less than 4. And then we had said, oh, what if we switch it up and say, why don't we graph x is less than 2 or x is greater than 4. Okay, so if you're cool with these kinds of problems, if you're cool with compound inequalities in the single variable, then when we graph compound inequalities in two variables, it's just gonna be a little extra step, but the thought process is the same. So remember, if we have an and compound inequality, then we are pretty much trying to find the intersection. And if we're trying to find the intersection, we want to know what is it that they have in common. Okay, so in this case, what do the inequalities have in common? But if we have an or compound inequality, then that's a slightly different problem. If we have an or compound inequality, then we're aiming to find the union. And then if we're trying to find the union, pretty much we're going to combine our answers. So that's it. Okay, so the question is, how are we going to solve this first problem? So it says, graph the solution set of each compound inequality. So remember, compound inequality is like two inequalities joined together with one of those connective words, whether the and or the or, depending which of the two words you're given, that will determine if you're aiming for union or intersection. So in this case, we have an and compound inequality, which means that we're trying to find the intersection. So let me go ahead, put a love note to myself. We're trying to aim for the intersection, so we want to know what is it that they have in common. Okay, so remember, in case I forget, pause and rewind as many times as needed. So this is how it's gonna go down. I'm gonna go ahead, write down the game plan for each inequality, and then we'll execute and then see what the intersection is. So for the first inequality, it's already solved for y, so that's nice. Let's go ahead and identify what we need. First things first, I want to know what is the slope, the y-intercept, and if the points on the boundary line are part of the solution set. Okay, so the coefficient of the x term is 1, so that's our slope. So we have slope equals 1. There is no constant term, so that means that the b or y-intercept is at 0. Fantastic. Give me a second, we're having technical difficulties here. Okay, cool. Again, and if you want to put a special effect 0, go for it. And now the question is, can I draw the graph of the boundary line? Well, the answer in this case is no. Why not? Because the inequality doesn't have what I call the equal to part. So I'm just gonna put dashed line. So once we do the graph of the boundary line, the question is, where is the actual solution? Are we going to draw, let's just say this is the boundary line. Are we going to are we going to shade above the boundary line or below the boundary line? So that's something that we talked about in the earlier video. So if you go with that above or below technique, because we have one of the is less than, then we will be shading below. Okay, so we have one of the is less than, so we shade below. So what I like to do when I solve compound inequalities, I write down the game plan for each inequality and then like execute at the end, because I don't like to lift my straight edge too many times. Second inequality, I'm thankful that it's already solved for y or in slope intercept form. So let's write down the game plan. So like identify what we need to graph the line and then make the call if we're gonna shade above or below the boundary line. Coefficient of the x term is -3, so our slope is -3. Constant term is 2, so b, which represents our y-intercept, is at 2. This inequality also doesn't have the equal to part, so we can't draw the graph of the boundary line, so we will do a dashed line. So again, remember, I go into further detail in terms of how to graph just one inequality in the earlier video, so go ahead, go back in the playlist. Now, once we do our dashed line, are we going to shade above the boundary line or below the boundary line? It's going to be the same speech. Because we have one of the is less than, then we're going to shade below. Okay, fantastic. So we got the game plan. It's not really necessary that you write all of these things. I know that you can just picture, but I recommend that you speak to yourself. Okay, write yourself a journal entry. Perfect. So first boundary line. So we have that the y-intercept is 0. Let's go ahead, locate 0 on the y-axis. The slope is 1. If we choose to write it as a fraction, we're going to write it 1 over 1. So our rise is 1 and our run is 1. So we're going to go up 1, 1 to the right. Up 1, 1 to the right. We had already established that the boundary line is out, so we have to fake graph it with our fake line, dash line. Don't tell the world I say fake line because I love my job, but that's just how I speak, okay? Cool. Alright, let's go ahead and do our fake line. Why do we do a fake line? Okay, I'll say bookwards. Why do we do a dash line? We do a dash line because although none of the points on the boundary line are part of the solution, we have to know where the coloring or the shading stops and all that good stuff. Because we are going to be doing 2 boundary lines, I'm going to go ahead and label this for my peace of mind, not because I have to do it for credit. So then when I look at my notes, a day later, a week later, the day before the test, I'll be like, oh yeah, this is the boundary line for the first inequality, or line 1. Let's go ahead and do the second inequality. So the second inequality, where am I? So the y-intercept is at 2. Let's go ahead and locate 2 on the y-axis. The slope is -3. If you choose to write it as a fraction, it's going to be -3 over 1. So in this case, the rise is -3 and the run is +1. So we're going to go down 3, 1 to the right. So from our intercept at 2, y-intercept at 2, we apply the slope, down 3, 1, 2, 3 over 1. We had already established that the boundary line is not part of the solution, so we have to fake graph it with our fake line. So go ahead, take out your ruler and straight edge. And as a student, I always freehanded these lines, because I thought I was like super awesome and this and that. But for students, I ask that you please use a ruler or straight edge to do your lines. Okay, so moment of truth. We are asked to find the intersection of these inequalities. So technically the only thing that I should submit for credit is the actual intersection. Where is the region that's below the first inequality and at the same time, oh, let me just put line 2. So let's go back 10 seconds. So we are trying to find the intersection. Okay, so I want to know where is the region that's below the first inequality. Where's the region that's below the first line and at the same time below the second line? If you're awesome and you're like, bam, it's right there. I don't know where I pointed to it, wherever my pencil landed, okay? If you're like, bam, it's right there, then go for it. But for me, it's really difficult, okay? So guess what? I have some special effects. Ooh, you like who needs technology? No. We're going to go old school, all right? Analog style. Ooh. So I'm using these transparencies that I printed in color probably like 20 years ago, okay? Yeah. Oh, I told you my age. Shh. Okay. For the first inequality, we want to shade below the boundary line, okay? So here's the first boundary line, and we want to shade the below part. So again, if you see it, cool, and if not, remember our finger trick from the previous video. You put your finger anywhere on the line. Below kind of reminds me, let's have a prettier finger. So we put our finger anywhere on the boundary line. Below kind of reminds me of going down. So I'm gonna move my finger down, and wherever my finger's touching, that's gonna be the below part. And again, if you don't trust yourself, instant replay. Put your finger elsewhere, and then move your finger down. That's the below part. Okay. So I'm gonna go ahead shade quickly. Yeah, I'm out of bounds, but it's okay. I'm not gonna cut it because I need it for another problem. Okay, so we have graphed the solution of the first inequality. Okay, now what is the solution of the second inequality? For the second inequality, we want to shade below. So here's the second boundary line, and the area below will be over here. Again, do the finger trick. You put your finger on the line and you go down. That will be the below part. Okay, so now remember, so we graphed the first inequality. Okay, this light right here is not working for me. Sorry. Okay, but I guess you can't have it all. Remember, we are trying to find the intersection. So the blue represents the solution set of the first inequality. The red represents the solution set of the second inequality. We were trying to find the intersection. So this piece right here, that's the only thing that we should be submitting for credit. Okay, so I take them out and then I shade right there. Now the question is, oh, Miss Torres, I love your special effects, even though they're a little old school, but I don't want to buy those special effects. Well, you shouldn't. So I'm going to show you how you can make your own special effects just with the pencil. Okay, we're going to see how this looks. Okay, you can see it. Okay, so we're going to If you want to do your special effects just so you can see the solution set, then this is how it's going to go down. We are going to shade each inequality, but we're not going to like color like we always do. We're going to do line coloring. So we're just going to do lines. Okay, cool. For the first inequality, we had said that we're going to shade below the boundary line. This is our first boundary line, and the below part is here. So we're going to do lines that are, you can't see that so well. Okay, everything worked good until you really need it. Okay, so we're gonna do lines that are below the boundary line. I typically don't make these dark. Okay, I make them pretty light, but the thing is, this light is not working with me. Okay, look, that's better. Who cares, we're in the dark. Okay, so one inequality down, one more to go. So we're gonna do the line shading as I call it. So let's go ahead, shade the solution set of the second inequality using the line shading. So the boundary line is right here and the below part is over here. So let's go ahead, do the line shading. Now I'm going to tell you why we're going to do it like this versus like our normal shade like we did in the previous problems. The reason is because I'm going to use this gray one to represent the pencil. If we color or shade fully, we're not going to be able to see the overlap. I mean, I have a special effect so you can see the overlap, but with pencil you're not. Okay, the advantage of you shading like this with the lines, but you have to make sure that the lines are perpendicular or perpendicular-ish to your boundary line. The reason why we do the line shading is so we can see what the intersection is. Wherever we have the crisscross action, that will be the intersection. Okay. So let's go ahead, shade it. So it needs to be when you submit your answer, the question that I get, how dark does it have to be? Well, that pretty much depends on how you started to how dark you made the other lines. When I look at your paper, it would be nice if I can see right away, oh, okay, this is the solution set. So I think that when the grader looks at my paper, they see the distinction, like this is my thinking area or my scratch work, and this is my answer. Now, if you have to scan in your work for whatever reason, make sure that sometimes the pencil doesn't look so nice. So if you have to, then go ahead, use a highlighter. Okay, for the answer. I don't want a highlighter for like your thinking area. Now, when you check your answer at the back of the book, the answer key is just an answer key. It's not a solution manual. So you're not going to see like our thinking area right here. You're only going to see the answer, which in this case is the intersection. Okay, cool. All right. So just to recap, for credit, do we have to show the work how we shaded each inequality individually? The answer is no. Okay, if you're like, I'm a genius, bam, this is the intersection, cool. If you're like, I'm a genius but I still want to show more work, cool, okay, more power to you. Okay, so we're gonna do a total of 4 problems. We're gonna have 2 and compound inequalities, 2 or compound inequalities, and then we're out. Okay, so second compound inequality, let me go ahead, turn on the light. Actually, oh, that was not good. Okay, I don't want to mess with this light, so we're gonna go like in dark mode, you know, romantic setting. Okay, so we have 2 inequalities connected with the word and. So gentle reminder, and compound inequality, we are looking for the intersection. So if we're looking for the intersection, we want to know what is it that they have in common. So we're going to graph each inequality and then be like, bam, this is what they have in common, wherever they overlap. Okay, first inequality, I'm thankful that it's already in slope intercept form. So let's identify everything that we need to draw the graph of the boundary line. So like the slope, y-intercept, and then can we graph the line. The slope of this inequality is 4. And the y-intercept is at -2. Now the question is, are the points on the boundary line part of the solution, or in English, can we draw the line? Because the inequality symbol contains the equal to part, then the boundary line is included, or we can graph it. So I guess we'll write solid line, you know, to keep it consistent with the book. Okay, once we do the boundary line, the question is, on which side of the boundary line are we going to shade? Are we going to shade above the boundary line, or are we going to shade below the boundary line? So because we have one of the is less than's, now we're going to shade below the boundary line. Fantastic. So game plan for one down, game plan for another one to go. Okay, second inequality. So at first I was very thankful, like, yes, this one's already solved for y. But check it out. This is not really in slope-intercept form, y equals mx plus b. Okay, we could force it, like put a 0x in front, but I don't know. Sometimes students are with me, sometimes they're not. So this is what we're gonna do. We're just gonna do a table of values to help us graph this line. Okay. So we have table of values, and in this case the value of y is locked in at -9/2, or in formal words, y has to equal -9/2. So we're gonna pick random values for x. Okay, so when we pick random values for x, let's just say 0, because you know, if you're with me since the beginning, then you know 0 is my favorite number. Well, only in the classroom. Okay, outside it's like I forget what my favorite number is. All right. So when x is 0, procedure substitute a 0 for x and then solve for y. But for this inequality, there's no x, so y still equals -9/2, which is the same as -4.5 or -4.5. Whatever works for you. So the ordered pair solution will be 0, -4.5. Alright, fantastic. To do a line, regardless of the technique that we use, we need 2 points. So in this case, go ahead, pick another x value. So my next favorite x value is 1. So procedure is substitute a 1 for x and solve for y, but there's no x, so y still equals -9/2. I'm going to go straight to the decimal point. Okay, so the ordered pair will be 1, -4.5. Alright, so we have enough information to graph the line. But now the question is, can we draw the graph of the boundary line? Are the points on the boundary line part of the solution? And the answer is no, okay, because there's no equal to parts. So I'm going to say dash line. Now, I feel a little bit uneasy to say above and below, so I'm going to take a pause right there. So we have our game plan. Let's begin to execute it, begin to graph each individual inequality, and then we'll take the intersection. Okay, first inequality. We already told the reader that we got this. Let's just execute it. So the y-intercept is at -2, so we locate -2 on the y-axis. Our slope is 4, so as a fraction, there'll be 4 over 1. So the rise is 4 and the run is 1. So we're going to go up 4, 1 to the right. Up 4, 1, 2, 3, 4, 1 to the right. We had already said that the line is in, or formal math, you know, points on the boundary line are included. So we're going to do a solid line. And then we could shade right now, but I'm going to take a pause on that. The reason why I don't shade right now is because if I do, then this coloring is going to get in the way when I try to do the other boundary lines. So I do the boundary lines first and then I shade. Okay, second inequality. We didn't identify the slope and y-intercept, but we have ordered pair solutions. So let's do it. So the first one is 0, -4.5. So from the origin, x is 0, so we're not going anywhere sideways. Y is -4.5, so let's go 4.5 units down. So stay put and then 4.5 down, right about there. Next one, we have 1, -4.5. So from the origin, 1 to the right and then 4.5 down. We had said that the points on the boundary line are not part of the solution, so we're going to do a dash line. Okay, I'm going to take my straight edge, hold it as best as I can, and then we'll do a dash line. I should have like music in the background, right? No, it's okay. I know you like my lovely voice. Perfect. Fantastic. And then I'll put L2 for line 2. So let's do this. So it's time for like old school effects. You know, who needs to use a computer? Not I. All right. The first inequality, we had said that we were going to shade below. So here's the boundary line and the below part is over here. Fantastic. The second one, we had said nothing, okay? But I really love this boundary line. Oh, I hope it's on the test. It's not. Okay. The reason why I like the second boundary line is because it's a lot easier for me to identify above or below. It's a horizontal line. If it's above, right there, below, over here, and I don't need the finger trick. So because it is solved for y, then we can use that above or below technique. And if it wasn't solved for y, then there's no above or below. So because we have one of the is greater than, then we're going to shade above the boundary line. So I think I moved this by mistake. Okay, for the first inequality, we shade below. Where am I? All right, the second inequality we are gonna shade above. Okay, so here's the boundary line and the above part will be here. Okay, so in this case we have to remind ourselves what were we trying to find? We were trying to find the intersection. So in this case it's the region where they overlap, so when we have this purplish tint. So that's what I will submit for credit. Now again, you guys are awesome, so you're like, oh, I'm on it, Miss Taurus. The region that's below the first inequality and above this one is right here. Go for it. You can go straight to the punchline. But if you want to show some work, I'm fine. Okay, so go straight answer or show some work. Okay, so if we show some work or additional work, because we've already shown work, the solution set of the first inequality, it's the region below this line. So it's over here. Let's do our perpendicular lines. Okay. So again, I usually don't make these dark, but I have to do them dark, else they don't come in the video. The second inequality, where am I? We want to shade above, so we have a horizontal line and the above part is over here. And wherever we have the crisscross action, that's the region that they have in common. So right here with this tic-tac zone is. So whenever I do my shading, it's a little bit easier for me to do the edges first. Reminisce when you were like 2. Oh no, that's too advanced. But reminisce when you were like 4 and you had to color in between the lines. Okay, so yeah. You see how like I'm not speaking right now? It's because I don't know what to say. And I need all my energy. I should have like music in the back, but I don't think you guys like banda or norteño, so we'll leave it like that. Okay. Alright, so we were asked to graph this compound inequality. So remember, compound inequality is when you take two inequalities and you link them with either the word and or the word or. If you have an and compound inequality, give me the intersection. Remember, in the answer key, you only see the answer, so you're not going to see this part of the line because this is not part of the intersection. You're not going to see this part of the line because it's not part of the intersection, and you're not going to see your thinking area. You're just going to see this right here. Okay guys, so I said we were going to do 2 problems. Where's my paper? Oh, it's right below. Okay, we're going to do a total of 4 problems, 2 and compound inequalities, 2 or compound inequalities. Let's go ahead and do the or ones, and then we'll be good for the day. Okay. So yeah, you can read those on your notes. Okay, so graph the solution set of each compound inequality. So we have an or compound inequality. So if we have an or compound inequality, then we are trying to find the union. Oh, I love finding the union. Why? Because to find the union, we're just gonna combine our results. I love combining our results because we just slap them together, and whatever that looks like, that is our answer. We don't have to worry about where do they overlap. So I don't really need special effects, but hey, I'm gonna make good use of my 20 cents. So let's do this. Unfortunately for this problem, neither inequality is in slope-intercept form, so that's the price we have to pay. Let's go ahead, get it into slope-intercept form, write down the game plan for each one, and then execute. Okay, first inequality, to isolate the variable term, let's go ahead, subtract 4x from both sides. And that will leave us with negative 3y is less than or equal to negative 4x plus 3. To finish it off, to get rid of the times 3, let's go ahead, divide both sides by negative 3. And then again, you know the drill. I want to remind myself at any point, if I multiply or divide both sides by a negative, we have to reverse the direction of the inequality symbol. So I'm going to say, let's bust out the sirens. Okay, but we'll write flip because we're not going to write those long directions. So that will leave us with y flip is now greater than or equal to positive 4/3 multiplied by x less 1. Alright, so let's write down the game plan. So write down what we need for the line and then make the call if we're going to shade above the line or below the line. So in this case, the slope is 4/3. Constant term is negative 1, so our y-intercept is at negative 1. Once we draw the boundary line, are we going to shade above or below the boundary line? Because we have one of the is greater than, we're going to shade above. But then I forgot, once we do the boundary line, can we actually graph it? And the answer is yes, because we have the equal to part. So I'm gonna say solid line. Sorry. All right. So we have game plan for one, game plan for the other one coming up. The second inequality, oh, I love it. Okay, so it's just one step. So to isolate the y, let's go ahead, subtract 2x from both sides, and that will leave us with y is greater than or equal to negative 2x plus 2. Fantastic. Let's ID what we need. The slope in this case is negative 2, and the y-intercept is at positive 2. Now the question is, can we draw the graph of the boundary line? The answer is yes, because the inequality has the equal to part. So we're going to say solid line. Once we do the boundary line, where are we going to shade? Are we going to shade above the line or below the line? Well, we look at the inequality. Because we have one of the is greater than, then we're going to shade above the boundary line. So we have the game plan. We have established that we're going to find the union. So we graph each one, and then that's it. That will be the answer. Okay, so where am I? So first inequality. Okay, y-intercept is at negative 1. Let's locate negative 1 on the y-axis. We apply the slope of 4/3. So rise is 4, run is 3. So up 4, 3 to the right. 1, 2, 3, 4, 3 to the right. 1, 2, 3. We had already said that the line is in. Okay, so we're expanding my words. The points on the boundary line are part of the solution. So this is why we can graph it. Please use a straight edge. Please put arrows at both ends. You don't have to label your line, but I told you my speech why. Okay, second boundary line, y-intercept is at positive 2, so let's locate 2 on the y-axis. The slope is negative 2. If you choose to write it as a fraction, then we can see that the rise is negative 2 and the run is positive 1. So we go down 2, 1 to the right, down 2, 1 to the right, and we had said that the line is also in or solid. Fantastic. So let's go ahead and do this. So we're at, so let's go ahead. Sorry if you see me stuttering and all that, it's because I'm looking for my special effects. So again, we are asked to find the union, so we graph each one, and then that's it. Okay, so where am I? The solution set of the first inequality. Once we do the line, we're gonna shade above line 1, and the above part is right here. Use your finger as needed. Okay, line 2, I could barely see it, but we are also asked to shade above. The line is right here, and the above part is over here. Okay, so remember, reference the earlier video. Okay, now we are asked to find the union, so we just graph it. We just leave it as such. Graph the first one. I'll just say shade the first one, shade the second one, and that's it. The only thing I ask is that you try to make the shading a uniform. Like, don't make this super dark, because then I'm thinking you're trying to find the intersection. Okay, so let's put that into practice. So we're not going to do any line shading because I'm not trying to find the intersection. So I want to actually shade it. The first one we're going to shade above. So let me just go like this. I'm not going to make it terribly dark. Okay, this is not good because you can't see it on the screen. But it's okay. I'll use my highlighter in a bit. I thought you were gonna see it because I had the lights off, you know, so we can be in a romantic setting. Okay, yeah, I think you can see it. All right. And then the second one, where am I? We also shade above. So here's line 2, and the above part is here. We already shaded this part, so I'm not gonna reshade it because then I'm afraid that it's gonna look darker. Okay. And if it looks darker, it could be interpreted as if this piece was the one that I was trying to submit for credit. Hopefully that made sense. I have to remind myself to stop moving my hand as I'm speaking. Okay, cool. So that's the answer. So I'm not sure if you can see it too good on the screen, because sometimes it looks different. So I'm gonna just go ahead and use my highlighter. I should speak, but you know what happens? Sometimes I don't even know what I'm saying when my hand is moving and I speak to it at the same time. Okay. Can you use a highlighter? Of course you can, but you have to be very comfortable, very confident in your answer, because you can't erase a highlighter. Okay, so remember, we were trying to find the union, so we combine our answers. So this right here combines the solution sets of both inequalities. Like, does this include the solution of the first inequality? Yeah, here's line 1, and that's the solution set in there. Does it also include the solution set of the second inequality? Yeah, here's line 2, and that right there is a solution set. So again, for union, I love union. Combine your answers and that's it. So I said we were going to do 2 or compound inequalities. That was the first. We have one more and then we're good for the day. Okay, so first inequality, unfortunately, it's not in slope-intercept form, so let's go ahead put it in slope-intercept form. So to isolate the y term, let's go ahead subtract 2x from both sides, and that will leave us with negative 3y is less than negative 2x minus 3. To finish it off, to get rid of the times negative 3, let's go ahead divide both sides by negative 3, and that will leave us with actually let me make a big fuss. Do you have to make a big fuss? No, but remember, your notes is like your diary. You want to put like all the juicy secrets. If you don't remind yourself like these little things, I'm pretty sure you're gonna forget to do them on the test, and that's not good. Okay, so love yourself. Okay, so that will leave us with y now is greater than, because we gotta flip it. Okay, is greater than positive 2/3 times x plus 1. Let's write down the game plan. So like, tell me what you need for the line, and then where would you shade after you do the line. Okay, so the slope in this case is 2/3. The y-intercept is at 1. Can I draw the graph of the boundary line? Answer is no. Okay, so we're gonna do dashed line. Okay, why? Because the inequality doesn't have the equal to part. Okay, once we do our boundary line, where are we going to shade? Are we going to shade above or below the boundary line? Because we have one of the is greater thans, then we're going to shade above the boundary line. Okay, let's write down the game plan. Second inequality, write down the game plan for the second inequality. Sorry. Second inequality does not have both the x and y variables, so we cannot put it in slope-intercept form. So it's okay. Depending on how you see things, you may just graph the boundary line right away, but you know the drill. You're not going to take the test from me, so I'm going to do it however I can, even if it means I have to show a little bit more work. Okay, so I'm going to go ahead and do an XY table. And usually we pick values for x, but in this case the value of x is locked in at negative 7/2, so we're going to pick random values for y. And you know my favorite ones, 0, 1, 2, and 3. Okay, so when y is 0, procedure says substitute a 0 for y and solve for x, but there is no y and x still equals negative 7/2. Okay, which is the same as negative 3.5 or negative 3.5. So let me go ahead and write that. So that will give us negative 3.5 comma 0. Okay, so negative 7/2 is the same as negative 3.5, I think. Yeah. So we need 2 points. We got 1 down, 1 more to go. My next favorite value for y is 1. So procedure, substitute a 1 for y and then solve for x. But there is no y, so x is still negative 7/2. So that will give us negative 7/2 or negative 3.5 comma 0. Okay, now the question is the boundary line part of the solution? The answer is yes, because the inequality has the equal to part. So I'm going to say solid line. Now, unfortunately for this problem, we can't do the above or below technique. Why? Because that's only reserved for boundary lines that are solved for y. Okay, I'm not sure if I addressed this, but forgot to write it. But let's just start from the beginning. Okay, so for or compound inequalities, we are asked to find the union. Okay, so we graph each inequality and then we combine our answers, and that's it, just like we did for problem A. Okay, or however I labeled it in your notes. Okay, so let's go ahead and do this. First inequality, our y-intercept is at 1. Let's locate 1 on the y-axis. Our slope is 2/3. So if our rise is 2 and our run is 3, we're going to go up 2 and 3 to the right. So let's do this, up 2 and then 3 to the right. We had said that the boundary line is out. So let's go ahead fake graph it with our fake line or dash line. Did I tell you about that joke? It's okay. I love my job. No jokes. All right. So let's go ahead and label it line 1. So one boundary line down, one more to go, and then we'll take the union. Okay. So the points are gonna be. I made a mistake. Ooh, good thing I caught myself. I would have been embarrassed if I published it to YouTube like that. Alright, so we have negative 3.5 comma 0. So from the origin we go 3.5 to the left, and then we stay put in terms of y. Second ordered pair, negative 3.5 comma 1. So from the origin we go 3.5 to the left, and then 1 unit up. Okay, thanks to our hard work we can see that we are going to have a vertical line, and in this case we're gonna do a solid line. Okay. So let me remind us, why is it that the above and below doesn't work when it's not solved for y? Well, the reason is if we don't have a y, then let me say it like this: if we only have the x variable, then the graph will be a vertical line, and if you have a vertical line, there's no like the above part and the below part. It's only left and right. Okay, I guess you could do like a similar, but no, too much information. So for the shading, we'll do like the test point version. Okay, so again, we are asked to find the union, not the intersection, so we're just gonna shade each one, and that's it. Okay, so for the first inequality, where am I? I keep losing my special effects. We want to shade above the boundary line. So the first boundary line is right here, and the above part will be right here. Okay, go ahead, start shading right now. Okay, the second one, we don't have a above or below, so we're gonna have to use the test point method unless you see it. Okay, so the test point method, to see which side of the boundary line that we're gonna shade, we're gonna test out any point of our liking as long as it's not on the line. And you know that 0 is my favorite number, so my favorite point will be 0 0, or the origin. So I'm gonna put TP, you know, my made up abbreviation for test point, and we're gonna test out the origin. So the inequality is x is less than or equal to negative 7/2, and we want to test out the origin. So let's see if the origin or whatever point you wanted to test out is a solution. So we have x, which we said is 0. I want to know if that's less than or equal to, let me go ahead and write this in decimal form. I want to know if that is less than or equal to negative 3.5. Oh man, is 0 less than or equal to negative 3.5? I'm like, no, that's a lie, because 0 is not smaller, it's actually bigger. I rather like break even than owe $3.50. Okay, so this is a false statement. So if we have a false statement, then we're gonna shade the opposite side. Shade the opposite side. Remember, our notes, treat it like a diary, like you want like all the achievement, all the juicy secrets. So please write down all those love notes. Okay, so for the first inequality, we were gonna shade above the boundary line. So here's the boundary line, and the above part is here. Okay, for the second inequality, our test point is right there. So let me get a better looking finger. Oh, I lost it. Where's my dollar investment? Okay, so our test point is right here. Sorry, our test point is right here, and our boundary line is right here. Okay, so remember, when we use the test point method to graph, if we get a true statement, then we're gonna shade the same side, meaning the side where the test point is located. But if we have a false statement, then we're gonna shade the opposite side, so like the side where the test point is not located. So in this case, we're gonna shade this part right here. Remember, we were trying to find the union, so too far. Okay, we are trying to find the union, so we're gonna combine our answers. You graph the first one, you graph the second one, and then you're good. Just make sure your shading is uniform, or like pretty much like what's the word I'm trying to find? Make sure it's like the same level of darkness. You know, don't make one super dark. Okay, so let me go ahead and use my pencil. So the above part was right here for the first inequality. So again, if it doesn't look good in the video because of the lighting situation, I'll use my highlighter. You know what? I'll use my highlighter anyways. Cool. And then the second inequality, we have to shade the opposite side. Boundary line is right here. Test point is right here. Opposite side will be right here. So it's going to be this whole part over here. We already shaded part of it, so I'm just going to shade the remaining part. Okay, so I think this looks good. Well, not really, doesn't look good on the light. Okay, but what I want to point out is that like the level of darkness is pretty much the same. So there's not gonna be a, we don't have to be worried about, oh look, the instructor's gonna think I submitted this for the intersection. Alright, so that was a good mental workout. So I think that's it. So I said we were going to do 4 problems, 2 and compound inequalities, 2 or compound inequalities, and we did it. Gracias. Gracias.